Hello, my name is Rainer Beudert, and I'm newly back into the OPC UA, and I'm coming from the Schneider-Electric digital factory, but I was already before when OPC still was kind of only for process control, back to 1998. And I tell a bit about this, the journey I did with that and with the requirements and where I'm pleased now to be in that, and I will do that with regard to a use case. A very simple use case all of you know, the use case of integrating machine into a line, into a plant, and all what is following out of that. So when you have a machine in the line, you may optimize the process or the machine, and you would like to, and in the end, we look back to the OEM, what does it mean for the OEM, and we draw a conclusion out of that. So first of all, we look at the challenges. So in the automation industry, 75% of projects exceed final budget, are delayed, or, if you look at the commissioning, there's a lot of spent time to identify, eliminate issues. So if you once have been in this area where it's all very often about communication, and it's very often about setting up the communication in between. Looking at this from an end user point of view, what is an end user wants to have? So he wants to have connected plan, seamless cloud integration we hear later, and he wants to have it custom focused. So that means he would like to have here, I've used your example, Peter. It's a washer, a filler, capper, labeler. So it's a filling line, which we have here. So this is already more or less the final situation. Everything is green. So maybe if it's equipped with Schneider, that's nice. But normally integration is done by a machine builder with different machines. So that means you have to have as well, if you have a communication in between the machines, when you want to set up the line, you need to engineer, or you go for you have OPC UA. So I give you an example. I go back. So I go back to this example. Once I was, just to remind on that, I was with the OMAC and PECML, and we decided with the PECML to set up a machine between different suppliers. And so it's very easy. We can use OPC. Yeah? So at that time, OPC UA server, everybody of our brands had an OPC server. But there was no client, so we had to go back to engineering. Now, as time is over, we look at what brings us OPC UA FX. First of all, the PECML is already in a companion spec, so that's done. And second is, now with OPC, what you just presented, the C2C, it is no more engineering. It is now a configuration of this exchange of data. So we easily set up a line for machine to machine or controller to controller and show this, how we interact the status, the state machine of PECML. We would easily now be able to do that. So that means, if we look back to the plant, we shorten projects. We can do things much more in parallel, as with the means of OPC UA, we have a much easier machine-to-plant integration. So once the machine is there, we would like to optimize maybe the machine. This is another perspective. We were first on the end user. Now we look back to, now we show forward, we have a data scientist who would like to optimize this machine. And if we look at this use case, as a data analyst, I would like to be able to securely read data from any controller and even any device. Maybe we have kind of secondary sensing or something. Opportunities for optimization of my production process. And I would like to be able to adapt it to my needs with the support and of the original equipment. So means I would like to have all the data wherever, from which supplier, which device it is, I would like to have it and would like to read it out. I was before, the last 3 years, I was on IIoT, and we had started together with a dairy company, an end user, we have started an AI project. And the first thing, what was the biggest difficulties you have in the beginning, how to get to the data. On this you spend really months. This is, and this is where I see the big promise in when I look in that. We have, so the companies are really motivated. They spent 43 billion of devices are so in 2023 already investing in this remote controlled machinery, connecting devices. But with regard to this lack of accessibility to the data, only 20% of this data is really then used. So you have always a gap there. And even with regard to all the potentials we have, you see the CAGR of nearly 40% in this until 2027, so we are on the way, but this is there we lack really a common standard. So what we did, first, when we implemented on our AI technology, the first thing I was asking for, please give me an OPC UA client so that we can read out the data at least. So this is already a first step, and to be able to apply this. So, what is the benefit then with OPC UA FX? So OPC UA FX is much more easier for if you have this to push IIoT data for analytic purpose, and interpreting this data and having it as well from different data models. As I said, you have the possibility with OPC UA that are predefined data models and which can be easily integrated into your plant, into your upper layer system by doing, let's say, energy optimization or comparable system, whatever it is. It's much more easier with OPC UA. So this was the second use case. And I have a third use case when we look at the machine integration from a machine builder's perspective. So I, as a machine builder, I would like to have an independent communication standard. Why? Because we are getting, as well as I'm from a supplier, we are getting this, if you have here a certain field bus, yes, is there enough devices supported? How can I communicate to the other machine in the line, and so on? This is where the difficulties begin. End users are very often have strict rules, and there is no accepted really accepted standard. So we worked hard on the PACML, we worked hard on the machinery integration in the ODVA, all of that, but there is no really communication standard, which is then as well going down usable for all motion safety. So you just presented this nice example of the safety implementation and the 5G. And there's another thing. I would like, if I do this communication, an additional communication, maybe for evaluation of analytics and so on, I don't want to have an impact, because this is very often the question. What do you communicate on this? And this is where we later hear as well about TSN, that we have this OPC UA FX with TSN, that we have a network and we have a base system which allows that. So looking at this, where have we been today? Each domain, so if I look from the machine, each domain has its own model, yeah, is separated. Yeah, even if we have, so the SE means Schneider-Electric, if it's SE has its own model. A fixed data model, yeah, you have fixed way, you have multi-layer data flow is not so easy to get. Yeah? So you have to jump over each of these layers. You start on the machine. I'm from Schneider. You start with Modbus TCP, and you go up, and that's then hopefully you have an OPC UA server. But all this is not so easy to grant. Even if when you look at the global on this. You have just a limited number of third-party devices and no conversion or limited conversions with IT. So we always have to discuss when we come with our OT protocols, they are not accepted. Are you on the list? So our big brother in Schneider is AVEVA. So as soon as you are, is this an AVEVA product? And you say, no, it's a Schneider product. Oh no, you are not on the list of IT, so out. This is where the message of Stefan is really great, that we have now as well the IT players on board, that we have really a conversion. Because otherwise you always have to, so in the OT there is an own world, but the IT is getting stronger and they would like to have a secure network down to the field. And this is where we start, and this is where this picture is really, really, really promising. Different layers, different models, and you can implement the same semantic. That's really nice. That's a promise. And you are flexible with the data models. I saw the companion specs are growing. I think it's even more than I know on automation is really there. We have a simplified data flow, and this is the promise, C2D up to cloud, with the security aspect. It's simplified. So you define a model, and you can evaluate maybe with an AI engine in the cloud. I was doing an AI machine in the cloud, and to get there, as I said before, getting on a device, doing a predictive maintenance, today is not impossible, but it needs so much players at the table to realize that this is nearly impossible. Then what we are achieving, we see all the brands on the list. We are achieving a great openness for the integration. And last but not least, what I said, the seamless integration with IT. That means OPC UA, so we see here what we are at Schneider, what we are implementing on this OPC UA FX on our next gen control. We are believing in this. Values, seamless communication, unified semantics from the sensor to the cloud. Everybody who has once connected a machine to a SCADA system or whatever knows what it means to have this unified semantics. Then this access to the data, an open access to the data, even if it's from a device, especially for the data analysts and so on. And last but not least, this unified security and safety and standard device profiles to have, and this is more or less the keyword, to have all of that on a deterministic networking. I mean, determinism is in the game. This is where I have to hand over to my next speaker. When we talk about TSN, this slide I have just for reading. It is okay, but I'm now exactly on 15 minutes. Okay, no, it's perfect. Thank you.
Thanks, Rainer.